everyone. My name is Barr. Excited to welcome you to my talk at Future Data Conference. We'll be talking today about what I think is one of the biggest challenges for the data industry today, and even more so in the next decade, which is data downtime. Looking forward to introducing the concept as well as data observability. What does that actually mean, and see some examples. So really excited about this. Without further ado, let's just dive right in. So just a little bit about myself. As I mentioned, my name is Barr. I am the CEO and co-founder of a company called Monte Carlo. We're named after the simulation, not the destination. And we are focused on helping enterprises increase trust in their data by reducing data downtime. I've worked at a number of different companies before in the data space. Most recently, I was VP at a company called Gainsight, working with companies on their on leveraging data as a competitive advantage. Previously at Bain and in the Israeli intelligence as well. And maybe the most important fun fact about me is that I'm a big Bruce Willis fan, so love all of his movies, and love them for many reasons. If some of you know, actually, I think Bruce Willis is a numbers guy as well. If you all have seen Die Hard 3, there was an important math problem involving water and jugs, which he solved in order to save lives. So check it out if you haven't. So that's just a little bit about myself. What are we going to talk about today? So as I mentioned, we're going to talk about data downtime. And I'll start by actually explaining what does data downtime mean, and what do I mean when I say the rise of data downtime, and why I think this is an increasingly important problem that we all need to sort of put our collective brains towards thinking about and solving. So let me actually start by talking about you all. If you've joined this call or if you've joined this conference, it's probably because you are in the data space and you see yourself in one of these or maybe another data persona. So perhaps you see yourself in Rebecca, who's kind of really experienced with spreadsheets and spends a lot of time trying to sort of tease out insights to bring to function like marketing, for example. You might see yourself as analyst Anna, who's sort of the SQL queen. Potentially you are, see yourself in Emerson engineer, spend a lot of time in BigQuery and Snowflake. And potentially manager Michelle, who likes to look at reports at Tableau and Looker and use those to make business decisions. So there are many different persona and types in the data industry, but there's one thing that's common to all of us, right? Which is we all rely on data, obviously, but also what's common is that we all experience kind of one thing or sort of a common thing, which is when someone downstream tells you that the data you're responsible for is wrong. Typically I would ask who had this happen to them, and most folks would raise their hands. So I'm assuming lots of people are raising their hands at home right now. I'll tell you a little bit about my personal experience with when someone downstream tells me that the data is wrong. So as I mentioned, I was at Gainsight, and back in 2016, I was responsible for the team that was generating data and insights for kind of usage across our company, as well as our board and our executives for decision making. And it was an interesting time because we were becoming data-driven as a company, and so we had a lot more data sources and way more data consumers, a lot more eyes on the data as well. And one of the things that really struck me was that during that time, it felt like every Monday morning I would wake up to this kind of sea of emails telling me that there was something wrong with some report. And it was always someone else who was finding the problem. It was rarely, someone on our team actually finding it. That was super frustrating because there are so many different reasons for why data would break. Someone would make a change upstream, something in the website changed, so many different reasons for why, suddenly the data wasn't fresh. In any case, it was really, I was really troubled by it because it just felt like it was kind of like a whack-a-mole game. We were trying to figure out, what's broken and where. And so, I assume that if you're in data, you've experienced something like this. And I think this is a big problem across the industry, which has implications sort of go beyond kind of personal frustration, right? So let's talk about what are some of the implications of this sort of happening in companies. So kind of three main areas of implication. One is, when we were kind of troubled by a lot of these sort of data incidents or sort of data breaking, we actually spent a lot of time trying to figure out what was the problem, troubleshooting and resolving it. And the funny thing about data problems is the later you find out about the problem, the longer it takes to fix it, right? Because you have to sort of rerun everything up until that point. And all of that is things all of that time is time that we could have actually used to roll out new products, to generate revenue, to do a lot of other things that actually could have been more material for the company, obviously. So that actually translates into real time and money lost. I spoke to an algo trading company a couple of weeks ago, and they described to me a scenario in which changes in their data, for example, like a schema change somewhere, could actually result in sort of changes in downstream reports and models that can result in up to losses in $10 million per week, in fact. And that's really material, sort of a very quantifiable way to see how bad data actually impacts lost revenue. The second main implication or main area is a compliance risk. Now, I think sort of a tendency to think that this is restricted for financial or healthcare industries, but actually almost all of us are at risk for compliance because of bad data. And that includes because of sort of the rise of CCPA and GDPR. But lots of kind of companies that deal with PII or credit card data are at risk of compliance if the data is wrong and if they're sort of involved with kind of inaccurate reporting. And then finally, obviously, erosion of trust, right? When we are kind of the product that we own is data, and our downstream consumers can't rely on that data, there's a very strong erosion of trust. Those downstream consumers could be internal customers, like, for example, data scientists or data analysts or functional units that are using data, or it could be external customers that are actually relying on our product or on our data for making decisions. I spoke to sort of a data team at a large e-commerce company, and they told me something very powerful. They said, when the data on our website is down, that's actually as bad or even worse than when our website is down, right? Because customers actually see data that is wrong, and that is a very serious loss of trust and confidence. And so, obviously, there's sort of a lot of kind of, material implications for this. And, there is, I don't know if this is good news, but maybe somewhat comforting news is that really no industry is spared from this kind of data downtime problem. Really affects companies across industries. Just as an example, in the last few months, it was reported that the government actually accidentally sent $1.4 billion in checks to dead people during COVID times. And you know what the culprit was? A table that was not refreshed, outdated table. Pretty crazy, right? And so, there's plenty of examples from different industries. I was just talking to a large tech company where the chief data officer told me, look, I really see this problem as the keep our CFO out of jail problem, right? Because of the compliance risk that this poses. And so, we're all dealing with this, but what do we actually mean, or sort of what's the definition of data downtime? Why are we actually calling it data downtime? So I'll start by saying I think it's actually important to kind of name this in a way that helps us understand what is the right approach to start dealing with it. So where does the term data downtime come from? It's actually a corollary to application downtime. So let me explain what that means. I'll take you back kind of a couple of decades ago. If your website was down, no one actually cared, right? Because very few people were looking at your website. And so, it was down, so what? Who cares, right? But today, that kind of seems ridiculous, right? We sort of meticulously measure uptime of our websites and our applications. And, every engineering team that respects itself has something to sort of manage that, to deal with application downtime, and to ensure that it's minimal. Now, I think data downtime as a corollary is actually as important, if not more important, as a problem, because now data is feeding all of our applications. So our application's actually running on data. And so, data is wrong in some places today, in some areas. Maybe we can get away with a report here and there that has, ARR slightly off or something like that. But you know what? I don't think that's going to cut it in the future. I think even today we're really, really cutting it close, right? But in a few years from now, it's not going to work. We're not going to be able to have data downtime, and we're going to need to get really thoughtful about how are we dealing with that in the same way that we've solved application downtime in the last few decades. It's really interesting. I think, the data industry in many ways is very kind of ahead of the game, right? We're really sort of pushing the edge in many ways, and we're very advanced in many things, with AI, GPT-3, all that good stuff. But also, there's some fundamentals here that we need to resolve, right? Data integrity, data accuracy, data downtime, all that stuff is stuff that we haven't figured out, actually. And so starting to piece that together and figuring out what does it mean actually will help us get to the future faster. So the proper definition of data downtime is periods of time when your data is partial, erroneous, missing, or otherwise accurate. Now, you might think, okay, fine, data downtime exists, sure, but why should I care about this, right? Why does it matter? Well, let me explain. I think you should care about data downtime because it's actually costing you millions of dollars and much more, especially if you're not doing anything about it right now. And even more so, it's going to get worse. It's sort of I would say data downtime is the biggest problem you're not actually thinking about. Now, a couple of sort of specific implications for what this might look like. The number of engineers that you have, or number of sort of data people that you have on your team that are actually spending their time on data fire drills. I'd encourage you to ask yourself, what percentage of time does my team actually spend on that? We see numbers all the way from 30 to 80% actually of time spent on this. And so, actually it's funny, I talked to a data team not too long ago where we're talking about data downtime, and they sort of told me, we really want to solve this. We've been wanting to solve data downtime for a while by building kind of an in-house solution for this, but we just never had time to get to it. And I was like, well, what's stopping you? What are you doing what are you doing instead, basically? And they were saying, we're just spending most of our time on fire drills, actually. Now, isn't that ironic, right? Instead of actually solving the problem from the root cause and being proactive about it, we are wasting so much time on data fire drills. Two other kind of material ways to sort of measure this, as I mentioned. Second is around compliance risk. So, just to sort of plug in a number, you can assume 4% of your revenue based on GDPR. And then finally, opportunity cost. So the revenue that you could have generated in other means if you were not spending your time on data fire drills. Now, tallying all these up, I would sort of argue that this is the annual cost of data downtime for your organization, and one that's actually worth, at the very least thinking about, if not even measuring, at the very least. So, as you can tell, think this is quite a big problem. Luckily, there's actually some solutions that we can start thinking about this. And, I'd say the place to start thinking about this is actually in other industries where, other solutions have been developed to solve similar problems, namely software engineering. So let me tell you a little bit about what does this mean in the second portion, where I'll talk a little bit more about data observability and how that relates to data downtime. So I mentioned that I think in many ways the data industry kind of has we have a lot to catch up on, right? And in many ways you have a lot to catch up on, especially as it compares to software engineering, right? The good thing, or the good news for all of this, is that this is kind of why software engineering was invented, right? In order to solve problems like data downtime, which is, maybe the best news of all. We can actually use our concept in software engineering to solve exactly these kinds of problems. So what does that actually mean? What I'd like to do is start by talking about observability, which is a concept from DevOps, which has been developed in the last couple of decades and have really kind of taken rise. So I'll start by explaining observability and then how that actually translates into data observability. So starting with kind of DevOps observability in particular, just as an intro, in case you're not familiar with it, software engineers actually leverage these principles of site reliability and observability to make sure that their applications are performing as expected, right? And so if you think about it, as kind of organizations grow and the underlying stacks that power them become more complicated, for example, as you're moving from a monolith to microservice architecture, it's really important for DevOps teams to have the right tools to make sure that all of those applications are actually healthy and running. And so observability actually speaks to this need and speaks to the different methodologies to make sure that the health of to make sure that the health of your applications and that you have good visibility into that. And so that includes monitoring, tracking, and triaging of incidents that help you prevent application downtime. Now, as a number of kind of industry-wide shifts that have happened, including kind of the shift to distributed systems, observability engineering has sort of emerged as a very fast-growing engineering discipline. And I sort of mentioned this before, but really every engineering team that respects itself kind of has something like this in order to understand the health of their application. And so what are the components of that? There are kind of three main components. One is metrics, which is basically kind of a numerations of sort of data over time. The second is traces, which helps kind of understand different events and how they're correlated. And then logs, which are actually like tracks of events at a certain timestamp. And sort of all of these together, kind of sort of in a nutshell, are sort of the pillars of observability, right? And so the question is, okay, if we believe that in software engineering we have a proper way to understand the health of our system with observability, how can we apply that to data? What does that mean in data, right? And so that is sort of how the concept of data observability was born. What is the definition of data observability? It's actually an organization's ability to fully understand the health of their data in their system, which allows them to thereby eliminate data downtime, again, on the same corollary. Just like DevOps, automated monitoring and triaging to identify and evaluate data quality and discoverability issues. Now, ultimately, the goal of data observability should be similar in that it creates more robust pipelines, stronger infrastructure, healthier and more productive teams. So, all theoretical so far, but what does it actually mean, right? Like, how do we actually see this in practice? What's kind of the reality that we can take today? Well, I'll present sort of three different concepts that I think we can actually implement tomorrow if you wanted. And in fact, the best data teams have already started implementing this. So let me sort of walk through a couple of these and hopefully you can try out one or two and let me know how it goes. So I'll start with the first, which is the 5 pillars of data observability. So we talked a little bit about the pillars of observability. And one thing to think about is that in general, applications can break for a million different reasons, right? However, we've aligned on a set of metrics that helps us understand the health of that system regardless of why it broke down. And that set of metrics includes things like latency, performance, CPU, right? And so no matter why kind of your application breaks down, we have this set of metrics to help us understand the health of your system. And so I'd argue that we need to define the same things for data observability. And those things are actually what you see here. And so these are the 5 observability pillars, which if you actually track these, if you instrument, monitor, and measure these, you actually will get a view into the health of your data. Now, what are these pillars? The first is freshness. So freshness is kind of a whole slew of metrics around the timeliness and up-to-dateness and availability of your data. If a certain table gets updated 5 times a day and then suddenly, it gets updated only 1 time a day, you need to know about that, right? That's sort of a freshness problem or potentially a freshness issue. The second pillar is around distribution, which is really kind of a measurement of at the field level, kind of the ranges of specific values. It can include, null values, negative values, or, potentially if you're kind of seeing a field that typically has values from 5 to 10, and then suddenly you're at 100, you probably need to know about that. The third is volume. So this could be like row count, byte size, whatever it is that helps you understand whether your volume is consistent or at least as expected over time. And the fourth is schema. So it's kind of like the organization of data. If fields are added, removed, changed from string to integer, you need to know about those changes. And then finally, lineage. Lineage is interesting in that it helps us create kind of a map or helps us put together the story of observability, helps us create events that are correlated between one another, so we can say, okay, somewhere here upstream there was a freshness problem, which resulted in a distribution problem here downstream, which resulted in sort of a corrupt report that someone is looking at and using to make decisions downstream, right? Now, lineage in its strong form actually includes metadata about all of these assets and helps automate some key elements of data governance and data catalogs. I think I was talking to a VP engineering at one of the leading financial companies, and they said, most of our data catalog is actually useless, except if it affects the reliability and integrity of the data, right? And so I think when we think about sort of what information do we really need to know and how do we automate that, we need to keep sort of reliability and observability in mind and make sure that that's captured there. So kind of the key takeaway here is, if you're looking for a way to think about the health of your data, having coverage for these 5 pillars and starting to think about what that looks like is probably a good first step to start creating observability into the system, into your data. So that's sort of the second one here, set SLAs and SLOs for data. So, this actually originated since VP of Data, one of our customers asked me, okay, awesome, I get the observability thing, I get data downtime, but, I want to start tracking this stuff and I want this to be an OKR for my team. What's the right metric, right? Like in DevOps, it's very clear, right? It's like 5 nines or incident rate or, errors and duration, all that good stuff. But we don't have that concept in data, not really. So how do I actually prove that we can get better in data downtime? And so we actually came up with this definition that includes 3 different components. One of them is sort of the number of incidents. So actually starting to track how many data incidents do we have. The second is time to detection. So how quickly are we finding when there's a problem with the data? Does it take you minutes, or actually are you finding this weeks or months after the data issue happened? And then finally, time to resolution. So once there's a problem, how quickly are we resolving it? Some teams, sometimes it takes sort of months to resolve issues because it takes so much time to figure out what the root cause is. Can we afford that amount of time, or how can we improve on that? Now, in order to think about how do we improve on data downtime, we kind of need to tackle each of these 3 components, right? So starting with time to resolution, we obviously need better tools and better methodologies to get to root cause, right? And honestly, more automated ways to get there. On time to detection, we need, a lot of the ways in which we find out problems today, going back to my example at the beginning, is when someone downstream says, hey, just want you to know that there's a problem with this report. If they're nice, if they're not nice, it might be like, an angry phone call. But how do we change that dynamic so that we are the first to know about problems and we detect them in near real time, That's really what our standard should be, near real-time detection of data issues. And then finally, a number of incidents. Actually, I think one thing that I hear a lot is kind of this acceptance that data downtime happens, right? This acceptance, like, yeah, data breaks, it happens. I don't know how many times folks, in the audience have heard this, but I hear this all the time. And I'm like, why are we settling, right? Why is it okay that we have data downtime and data incidents? Actually, we're finding that there's ways to prevent incidents to begin with. When teams have strong visibility and strong observability of their data, you can actually prevent incidents, because when you're making changes or when you're sort of building and moving fast, you are aware of your surroundings and you know who depends on you. And so actually, by being proactive and having that observability to begin with, the number of incidents just goes down dramatically. So I do think that actually starting to track this is perhaps, the very first step in order for us as an industry to kind of get a handle on this good stuff. So then kind of the third point here is around automate. If there's one kind of thing that we really learned from, or I really learned from sort of modern software engineering, is that, automation is our best friend, right? It doesn't mean that we don't have humans. Of course we do. But to the degree that we can automate things, we should look to that, right? I think it's very common today to have best practices like, we always have like 6 sets of eyes to vet a report before it goes out, right? Like I personally had a process like that. When I was leading my team, we would always have these like, at least 2 or 3 people looking at a report, kind of like sanity checking it, and actually spend a lot of time vetting that. And honestly, like, I think that could work like 5 years ago, but like not today, not with the amount of data that we have, not with the amount of data demands that we have on the teams that are producing and consuming data. We have to move past that and start turning to automation. On top of that, if you actually we looked into how much time do people actually spend on bad data. And, folks at New York Times say 50 to 80% in an article that they published. HBR says 50% of a data team's time. That's a significant amount of time, right? And one that we have to believe can be at least reduced significantly with automation. So just to summarize here, hopefully sort of, you all kind of got a good sense of the concepts of data downtime, data observability, and where I think we're going with the future. Just to summarize, as I mentioned, I really believe that data downtime is the biggest challenge that our industry is facing, one that we cannot continue ignoring, and one that will in fact get worse and worse as we progress as a data industry. If there's one thing that I know is true, is that we're all getting more data driven, not less. And hopefully if you're on this talk, you agree with that. And that requires solving data downtime, right? Now, the good news is I don't think we need to reinvent the wheel. There's a lot of good stuff in other industries and some best practices that we can sort of rely on, specifically the concept of DevOps and software engineering. I think data observability is an important first step for us to start alleviating this pain, and one that actually can help data teams move faster towards this future that we all want. And so I'll leave you all with one thought here, just kind of a parting thought. I think in the past, what did being data driven mean, right, in an organization? In the past, companies used data to report to the street once a quarter, and there was basically sort of a fairly large group of people that were responsible for a small set of reports. And so that relied on kind of manual processes and people making judgment calls based on data, right? That was sort of, what you call the old world. I think the future is going to look very different. I think in the future, large groups of people are going to be looking at large amounts of report in real time and all of the time. And you can see companies like Netflix, for example, and Uber, where more and more people are actually using data for real-time decision making every day. Actually, thinking about this even more, in the future, we're likely going to have machines making automated decisions based on data, right? And so if you believe in that future, and if you believe in that kind of reality, which is coming upon us, there's a catch in this future that's coming. To allow for this future, we need to get the fundamentals right. Now, I know it sounds counterintuitive, right? We just want to run forward. But actually, if you think about it, we have got to figure this out. We sort of have this natural desire to kind of jump to the next object. But I'd argue that in order to enable that, we have to go back and figure out accuracy, integrity, and observability so that we can enable trust, enable teams to have the confidence to create this future. Now, the good news is that depends on folks like yourself. And, I really hope that you join me in creating this awesome future and making it a reality. So with that, thank you so much. I hope you enjoyed, and I'm looking forward to seeing you all in the Q&A.
When you are busy, people making you dizzy, better watch out for data downtime.
There's something so powerful in having language to identify and communicate the problems we experience in life. Without this ability, things feel chaotic. Like when on the last day of the month, someone modifies the exchange rates table, ultimately causing you to understate revenue as the books are being closed, and you don't find out about it until the head of sales questions the numbers in your dashboard. Yes, data downtime. It's a thing, and there are tools and strategies for managing it. Huge thank you to Barr and Monte Carlo Data for introducing us to the concept of data downtime. We've got a 15-minute break right now, and I encourage you all to head over to the Future Data Slack community to continue this dialogue. Finally, whatever you do, future data is, don't forget, the plural of anecdote is data.